Hello girls. Hello girls. Welcome to the lecture of Digital System Design. Today we will be discussing about VHDL, a hardware description language. The objectives for the sessions are: you will know the structure of VHDL, you will understand modeling types of VHDL, and then you will be able to declare entity. So in entity, you declare ports, you will be able to declare modes in ports, you will be able to declare generics, constants and variables. Now, if you talk about VHDL programming, the very first stage in VHDL programming is device selection. You are aware that we can program either on CPLD or FPGA by using VHDL. So, the particular device what you are using, it should be defined in a device. The next thing is, once you decide about the device, you start writing your program. So whenever you write a program, you declare a library. So after declaring a library, we go with a entity. Basically in entity, we define input, output, constants, variables, all these things which will be going to use in furthermore architectures we are defining them in entity. And then the entity is followed by architecture. And if you talk about architecture is a thing where we can say that exactly how the device is going to work. There are three types of architecture: behavioral, structural and data flow. So you will be able to understand what are these types of architectures here now. Now if you talk about the first architecture, behavioral, you can see in an example that behavioral architecture start with the process. Okay, see this, we have defined an entity. You must have did a programming for your lab. In that, you are the first stage, you can see we have defined a library. We are saying that we will be using standard logic library 1164, all the components. Then we define entity there. And if you observe in the architecture, we are using process statement here. Okay, so it is more kind of a C type of programming. So you can see this instruction as well. If A and B is equal to 0, then C assigned with 0, else C will be assigned with 1. Such type of programmings you must have done in your C programming. So it is kind of a sequential kind of programming here, which can see that this is a pattern in which we do programming in behavioral. If you talk about structural programming, the things will be same, like defining library, indicating which library we are going to use, defining entities, what are the ports we are going to use. And in architecture, you can see that we have defined a component first. Okay, here AND gate is a component which has been defined with the input and outputs there, and that component has been called again in architecture like this, and the port is mapped with ABC. So we are not changing the port names, so that is why it has been written as like this. So if you see programming of such kind, VHDL programming of such kind, you will be able to say that it is a structural programming. Okay, so if you see component, it is a structural programming. Next, the thing is data flow. Data flow, what we are using in our lab sessions. You see, library we have defined. We have defined the library which we are going to use like a previous. We are defining entities like previous two examples. Only the thing is, data flow mein you are just writing C assigned with A and assigned with B. So all these three examples A and B are related to a two input AND gate with inputs as A and B and output as C. So with these three, one example we have written it in three ways. It may be possible that when you write a VHDL program, rather a big VHDL program, you may jump in between these styles. So there are three modeling styles. One can program in any one or prefer, or someone can use all the three according to his feasibility. So as we know that in all the three we have used entity. So entity is a very important thing, and it is a model that interfaces architectures. So this is a model which defines interfaces. The entity defines how a design element described in VHDL connects to other VHDL models. Okay, so that there we are defining the input and output of architecture, whichever we are going to use. It also defines the name of the model. So it is important that whenever you name the file, you should name the file as per your entity name. So this is important. Okay, it allows the definition of any parameters that are to be passed into the model using hierarchy. So you can define parameters there in entity itself, and those parameters could be passed according to the hierarchy. So now here you can see that one two-port network has been shown to you, which is a half adder, and that half adder has two inputs as A and B and output as sum and carry. Okay, if you want to write entity for this, how will we write? So you can see the on your left hand side, entity test is entity and entity test. This is one way of writing entity, declaring entity. The first is the syntax is you should have entity is, and in between these two words there should be the name of the model, whatever the name of the model is. Okay, that should appear here. Like if you are writing it for AND gate, you may write it as AND gate. If you are writing for 4:1 multiplexer, you should write down there as 4:1 multiplexer instead of test. You can put any other name there. Okay, at the in between those dotted line we are defining the things, whichever the like port values A, B, sum, carry, these things will be defined there in between that, and after that we are ending the entity by writing as end entity and the name of that entity, name of the model. Okay, so this is the way we end it. The another way of writing this entity test is, say, similar line or as of earlier one, or dot means here we are defining entity and at the end is end test. So it is not necessary that you should write end entity and the name of entity. We can just write it as end the name of entity. So now when we say that we are what we can define in entity, we can define ports. Okay, so the structure of defining port is the method of connecting entities together is using ports. Ports defines the method of connecting entities. अब जैसा ports are defined in the entity using the following method. कैसे define करते हैं? Series bracket start and then list of port declarations. Whatever port you are defining, say A, B, sum, carry, these are the things we will be defining here, and then we are closing it like this. Okay, close bracket and semicolon. Now let us see the example. Like the port declaration defines the type of connection and direction where appropriate. Port in 1 in 2 colon in bit. This is the way we define port. It means to say that there are two inputs. The inputs are named as in 1 and in 2, which who are functioning as a input to the device, and then the data type is bit. Okay, and then you are putting semicolon and you are defining output as out1 colon out bits. Again like that, out is a nature of the port declaration parameter and bit is a data type, and then you have to close the bracket like that. You can see that, you can observe that semicolon is appearing after the bracket and not before the bracket. This is what you should remember. Now we have in It's a in signal values are read only. Then you can define ports as either in. So in the when you define it as in, it will always appear on the left hand side of a block. It will always appear on the left hand side of the block, and it is read only. You can define in out. When you define it as out, signal values are right only, and they'll appear on a right side. Okay. When you define it as a buffer, so buffer is comparable to out, but you can read this. You cannot read out, it is right only, but if you define the things as buffer, okay, things will be getting out on that, but it can be readable. Someone can read it. The possibility of reading is both the way. It will appear in both the sides. Okay. So next is in out. In out means bidirectional one. It can appear there in the input side, it can appear in the output side. So in out can appear in a both side. So we can read it. It is true bidirectional one. Okay. Then the first thing we have learn is we can define ports in entity. Then we can define generics in entity. So the generics are actually the model parameters. Okay. You define it like this: generic as gain, the nature, the data type for this is integer, and the value for this is 4. So you have assigned, say assignment is colon equal to, the assignment pattern for generic is colon equal to, okay, and the data type declaration is like previous example, colon after colon. So the name of generic is gain, it is an integer whose value is 4. Then you are putting semicolon, it's because you want to define the second one. In the second one you are saying time delay. Okay, you named it as a time delay. Again you are defining its nature, data type as time. This is a time. So after colon whatever comes is a time, and then equal to 10 nanoseconds. You have used a term as equal to 10 nanoseconds, and you are not putting semicolon there, but you are putting semicolon after the block. This is the way you define generics. So two things we can define in entity: one is a ports, other one as a generic, and the third one is a constants. We can define constants. So it is also possible to include model specific constants in the entity using the standard declaration of constants method. Constants like this: constant, the name of constant as r pull up, the nature as real, and the assigned value is like this. So this will remain constant throughout. Okay, this is the way we can define generics, constant, and ports in entity. Okay, after that complete model where we will be defining port. So we'll write as entity test is end entity test. This is the standard way. Okay, whenever we define entity, we have to define in between these two. Entity, the name of entity is end entity test, or you can just write it as end test. We have defined here a port in 1, in 2, in bit, out 1, out bit. Then we will define generic gain integer 4, time delay, time equal to 10 nanosecond. So whenever you are assigning any value, you have to put as colon and equal to symbol. Okay. Next to that is end entity, sorry, constant we want to define. This is the way we defined a constant. So whatever the things we have seen a structure of a VHDL. After that we have seen modeling types. Which are those modeling types? Behavioral, data flow, and structural. Behavioral is similar to our C programming kind of thing. Okay, structural is where we define components and use them further in architecture, and data flow is simple. Okay, next to that is we use entity in declaration, and whenever we are declaring anything in entity, we will be declaring ports in entity. When you declare ports in entity, the ports could be having in out, and buffer. These are the 4 modes of ports in out, buffer and in out. Then we have seen to define generics, constants and variables. So variables we will be seeing further. Okay, got this. So these are the things which we learn. So if you have any comments, questions, you can put there below this. You can contact me on this number or you can mail me on this. Thank you.